I'm going to share my screen and, oh, I'm on the wrong slide. Let's see here. Okay. Awesome. So hello, everyone. Welcome to the Science Symposium. I'm really excited to be here with our judges and with Jueqi today. So yeah, we have Dr. Nidhi, Dr. Gabriella, and Jueqi who'll be doing her presentation. And we also have Noeen in the background today. She is the chair and brainchild behind our Science Symposium, and she's been the driving force in putting this all together. So you'll definitely hear her voice a few times. And I'd like to also introduce myself. My name is Ashley Vanderpapgram, and I have the honor of being the vice chair of the symposium and moderating with you all today. So before we get started, I would like to take a moment to acknowledge that we are, or that at least with SCWIST, SCWIST Vancouver is located on the traditional and unceded traditional and ancestral lands of the Musqueam, the Tsleil-Waututh, and the Squamish people. And just always just making a note that's great to reflect on whose land we're on and how we obtain that land and the stories behind them there. So we are in our first presentation in the machine learning artificial intelligence category. Jueqi will be doing our first presentation. So we're very excited to have you. And before we get started, I would like to go over a few housekeeping rules. As you've noted, today's session will be recorded and it will be put on YouTube within a day or two. And please keep yourself muted when you are not talking. And for those who are listening, if you have any questions during Jueqi's presentation, please drop those in the chat box, as we will be asking those questions after our panel discussion with our judges. Another reason the Science Symposium wouldn't be possible is without our sponsors. So we have a lot of really great sponsors who have come on and helped make this possible. One of them being Northeastern University, Vancouver, who has a over 95% employment rate for biotechnology. So if that's an area you're interested in, please check them out. We also have ADME or Bioinnovations, and if you want to polish your skills in business or science, please check out their programs. 𝐉𝐔𝐃𝐄𝐑, who discovered the antibody that neutralizes the viral variants of COVID-19, have also signed on, so we're very happy to have them. As well as Acuitas Therapeutics, and their lipid nanoparticle delivery system is a key element in the development of Pfizer's vaccines. Another really fantastic company there. We also have Microsoft. So if anyone's interested in internships in IT, please check out their website. And we have Malik Surgical, who uses cutting-edge magnetic technology to improve breast cancer patients' experiences. So another really great company to check out there. Now, we do have our two judges that I will give the opportunity to introduce themselves. And then we'll move on to you, Jueqi, so you can introduce yourself and begin your presentation. So first, I will start with Dr. Nidhi. Would you mind sharing a few lines about yourself?
Sure. Hello, everyone. I'm Nidhi Rastogi. I'm an incoming assistant professor at Rochester Institute of Technology. And for the next couple of weeks, I will continue to be a research scientist at Rensselaer Polytechnic in New York. My research focuses on using AI, machine learning, deep learning, knowledge graphs, and applied cryptography to problems in cybersecurity for a variety of platforms. And I'm excited to be a judge on this panel and looking forward to Jueqi's presentation. Good luck.
Wonderful. And Dr. Gabriella.
Hi, I'm Gabriella Pizzuto, and I am a researcher at the University of Liverpool, where I work on robotics platforms, and I am currently developing a mobile robotic chemist for material discovery. I was previously working at the Edinburgh Centre for Robotics, and I got my PhD in computer science in Manchester. And my research interests are combining robotics with applied machine learning. And I look forward to Jueqi's presentation today, and my best wishes for your presentation. Thank you.
Wonderful. And with that, Jueqi, I'll let you say a few lines about yourself to introduce yourself, and then you can head on into your presentation.
Okay, so I am a first-year graduate student at St. Francis Xavier University, and then I will start my presentation now. Okay. Oh, so. Now you can see my presentation, right? The PowerPoint, right?
That's right. Yeah.
Okay, great. So I'm very happy to present our work on multi-channel input pixel-wise regression 3D UNet for medical image estimation with 3 applications in brain MRI. And this is a joint work by myself, Dirk Berger, David Marty, and Dr. Jacob Lehman, who is also my supervisor. So this is the outline of my presentation. Firstly, I'd like to talk about the purpose of our work to give you an overall understanding of what we are doing. Then we'll talk more detailedly about our method and 3 applications we have applied our model on. Then we'll give you the result of our experiment and the conclusion of our project. Then we'll briefly talk about the future work I'd like to do on this project. The purpose of our work is to develop a robust and versatile deep learning model to solve a variety of medical image estimation problems. So for image estimation problem, we want the deep learning model to estimate an image. So the output and the input of the model are also images. Method UNet or 3D UNet is a deep learning architecture designed for semantic segmentation of medical images. Semantic segmentation is to classify each pixel in the input image. I show an example of semantic segmentation. The model needs to tell which pixel are background and which pixel are human. UNet has become a widely used benchmark in medical image semantic segmentation. So in our work, we propose a multi-channel input pixel-wise regression 3D UNet for estimation of medical images. We use 3D model is because a lot of medical images are 3D. A 3D UNet seems like an appropriate method to deal with that. Unlike normal UNet, we're using a regression layer as a final layer, and we want to estimate the intensity value of each pixel in the image. Method. We use a 5-layer 3D UNet architecture modified from VNet. We use the Z-score intensity normalization, and we use the mean absolute error as a loss function. We have also tried the mean square error, but the mean absolute error would return better result on almost every measurement we're using. Also, it is worth mentioning that for image-to-image translation task, MAE is a more widely used loss function than MSE. For the task which we can use more than one image as input, we are using multi-channel input, which means we concatenate those images in the channel dimension, and we compare multi-channel to single-channel input in our work. We're using 𝐒𝐏𝐄𝐑 as activation function with alpha equal to 0.2. This is because we use the Z-score intensity normalization method, which makes the input image has negative value. So we use the 𝐒𝐏𝐄𝐑 activation function. And this is the learning rate and optimizer we're using. So for application 1 is longitudinal image estimation. We want to predict a pending MRI examination of patients with Alzheimer's disease based on previous rounds of imaging. We use the Alzheimer's Disease Neuroimaging Initiative dataset. We use AD subjects with 4 longitudinal MRI screens at screening, month 6, month 12, and month 24. We totally used 88 AD subjects with 70 subjects for training and 18 subjects for testing. You can see the visualization part below. The background area are different shadow of grades. This is because we use the Z-score intensity normalization method on each volume. So the visualization part looks like this. In this application, we have tried with 3 different inputs. The first is using the screening, month 6 and month 12 to predict the target image month 24. The second is only using month 6 and month 12 to predict the target image. The third is using month 12 to predict the target image. The second application is diffusion image reconstruction. We use our model to process the 4D diffusion exam into fractional anisotropy and apparent diffusion coefficient volumes. We use the Human Connectome project dataset. We use 19 MR diffusion tensor exam with 16 for training and 3 for testing. Because the dataset is extremely small, we also apply data augmentation in this application. The third application is modality estimation. We want our model to estimate one type of MRI examination from a collection of other types. We use the breast 18 to 20 dataset. We use 1,305 subjects with 1,044 subjects for training and 261 subjects for testing. And in this application, we want to estimate T2 flare MRI from T1 and T2 or only T1 MRI. We want to estimate T2 from T1 and T2 flare or only T1. We also want to estimate T1 MRI from T2 and T2 flare or only T2. And this is the qualitative and quantitative result of our model. The result demonstrates the improvement in the measurement from the use of multi-channel input related to single-channel input in longitudinal image estimation and modality estimation. Multi-channel input is required for diffusion image reconstruction, so we cannot compare that there. So for example, in the longitudinal image estimation, when we are using more than one schemes to predict, the result is better than only using one schemes to predict. Conclusion. In this project, we propose a multi-channel input pixelwise regression 3D unit for medical image estimation. And we show the pixelwise regression 3D unit is a robust and flexible architecture to be able to handle these 3 applications with minimum reconfiguration. We actually only change the input number of channel and bench size for every application, and it could be used for these 3 applications. Future work. I will try different normalization methods to see whether results will get better or not, because using the Z-score intensity normalization method on each volume may not be the best way to deal with MRI. I also want to try with other loss function, because the way human measure 2 images are very different from the way MAE did. MAE only look at the pixel individually, but human visual system is turned to focus on groups of pixels. So I think if we can find more suitable loss function here, we should get better results. And I'd like to take the time to thank everyone, my supervisor and the wonderful people I have worked on with this project at SCWIST and judges and everyone who has participated today. Thanks for your listening, and thanks a lot for providing me this opportunity. I'm looking forward to answer any questions.
Wonderful. Thank you so much, Jueqi. I would like to pass it over to our judges for a Q&A. This is pretty flexible. You can take turns asking questions or ask all your questions in a row, whatever you would like to do.
Sure. I just want to ask a few more questions which are more informative, just to gather more about the project. So number one is, are these data sets that you've included in application 1, 2, and 3, Are these real data sets, or did you capture them from elsewhere? The data
This
set that you use.
Oh, can you still see my PowerPoint now, or?
Yes, I do.
Okay, so in these three data sets, they or like real data set, or open source data set you can find online.
Okay.
And yes, and we for application one, there are huge data set, and we take the AD subject we want to use from there with 4 schemes. And for application 2, I think we pick some image from there. There should be a lot of the 4D diffusion exam, and we pick 19 exams. And for application 3, this is a like well-known data set with multi-modality one, and we use all of them to train and testing.
Okay, but do you use them separately for training and testing, or just so application 1 was trained and tested separately, 2 was trained and tested separately? Is that how it worked?
Yes, we just supply the data set into train and testing. In the future work, I actually also do the K-folder cross validation on those 3 applications.
Okay. That was one question. And my other question was, so one was the real data set. So is this an ongoing research, or is this a finished project?
This is still an ongoing research, ongoing project I'm still working on, but we have published a short paper on it in MIDO 2021. You can search the paper online.
Okay.
Yes, I'm still working on this.
All right. So the question that I have is more along the lines of understanding. So when you're converting this data, which is 3D and 4D, like multidimensional, into 2D, because the pixels are anyways captured. So how are you making sure that there isn't a loss using the z-score intensity normalization function, or is this something what you're going to be working on in your in your future work to understand if there is a loss based on what function you're using?
So our output image is also 3D. We put the 3D volume in there, and the output is also 3D.
Okay.
So yes, and I do think the z-score intensity normalization should lose some information, because actually for the same MRI machine and using the same protocol, the intensity of the patient should like include some information. But if we're using the z-score intensity normalization, we would lose that. So I'm still thinking about other ways to deal with the normalization method.
Okay. And are there any other alternatives that you plan to look into?
So my supervisor wanted me to test or using the maximum intensity from the whole data set. But for each MRI volume, it's actually verifying a lot. Some maximum intensity probably have 1,000, but others have 100. So I'm quite doubt about it. And another way to deal with it is dividing by the intensity volume from the same machine, the same protocol. Like if the data set process the patient with the same machine in the 4, like in the longitudinal test in the 4 schemes, and we can like combine the 4 schemes together and use this maximum intensity value from the 4 schemes to do that. I think that probably is a better way to deal. I still would do the experiment on zero to see
Of course.
if it would be better result. Yes.
Okay, thank you.
Yeah.
Thank you for your presentation, Jueqi. I really enjoyed your talk. So I also have some other some questions which might be a bit more technical, and some of them might be more application based. So my first question was, why did you choose the UNet? Like, there are other segmentation architectures, and I was curious about the motivation for choosing this particular architecture.
I think, as I have mentioned in the presentation, UNet is a widely used model for medical image. I'm not sure about generous model on this, but UNet really achieved good result in the medical image semantic segmentation, and I only try UNet, so I haven't tried with other model. Yeah, so if there are better model, please let me know, and I'm very happy to try with it.
So I don't know the field particular, but there are the segmentation models. So I think one of the other speakers would talk about, for example, regional convolution neural networks. I don't know if that would also be applicable, but I was just curious if there were any other architectures you have looked into, but that's okay. Thank you for your answer. I think some of my questions are also follow-ups from Nidhi's questions. So I was also, you mentioned cross-validation. And when I saw the presentation, I was wondering why you used a train test split rather than a train validation test. And also following up from that, how did you decide on your split? So how did you decide on splitting up the data?
So I haven't done with train validation testing. I only split my data into train and validation. So I think I might do that in the future. And I simply split the data randomly into, I think it should be 0.8 80% of my data is for training, and 20% of my data is for testing. I remember, so.
Okay, thank you.
Just randomly split.
Okay. And again, I was wondering about your choice of hyperparameters. So when you chose the activation function, the learning grade, the optimizer, how did you settle on these selection?
I actually try a lot of it, and this gave me the better result. So I combine them, and we want because there are 3 applications, we want all the 3 applications to achieve not bad result. So that's from the experiment part.
Okay, thank you. And also, you have, as you were saying, you have 3 applications, you have 3 data sets. I was wondering whether you chose the application, the data set for the application, or you chose the data set because you wanted to explore your models given the characteristics in the data set.
So I think we firstly come up the application, and then we find the suitable data set.
Okay. And my last question is, you were talking about different loss functions, and you mentioned that in future work you would like to explore more biologically plausible, let's say, loss functions. How do you get this intuition that these would be better? Have you read some related work that they show that this is better? Why do you get this intuition that this might be better?
Yes, I did read some paper about it, because there is a metric called SSIM. Can you see my PowerPoint?
Yes,
in the result part?
Yes.
So in the result part, there is a metric called SSIM, and SSIM actually, like instead of from MAE or MSE, it actually looks the image from a more like general way, like humans way. So there is a paper from I think 2018 or 2017. They test on the loss function from also on the image-to-image translation task, and they find out that when using MAE and I think they use multi-scale SSIM, quite similar metric with SSIM, and they find if they compare it together, it would return better results than MAE. So I would continue to do experiment on that to like find out. That's a really good question, and I do think about it for a long time. Thank you.
Okay, thank you so much for your answers. I think that's it from my end. Thank you for the presentation. I really enjoyed it.
Thank you.
I do have a few more
sorry.
questions. I actually wanted to understand two things. One was on your application 3 slide. This is slide number 9. Yeah, could you walk me through what does this mean? T1 plus T2 results in T2 minus flare.
You can see my slide, right?
Yes.
Now, the application 3. So for T1 and T2 and T2 flare, they are different MRI modality. Like we see the same like objects from different way, and so we have 3 different volumes, and for T1 plus T2 means we use T1 and T2 images and we use we concatenate them in the channel dimension, and we put the 2 image into the model, and we want it to estimate the T2 flare MRI. Is that clarify myself?
Yes.
Okay, thank you.
And so that was the first one. What does this one mean? T2 results in, sorry, T1 result, the one underneath. Yeah, this one. The one before.
It means we only use the T1 image to estimate T2 flare image. So we only put the T1 image into the model to estimate the target image. We do not use the channel dimension is only 1 because we only have 1 volume here.
Okay.
So, okay.
Next question is about your results slide. Yes. So, so the ones which are, the ones which are bold, I'm assuming means that they are the ones which outperformed in that specific task.
Yes.
Of the methods. So, what do you think? How did they outperform the other ones, and what would be the reasons? Could you summarize that?
You're asking for the longitudinal image estimation when we are using the more image to estimate, but the result is not better than only using 2 image to estimate, like the first row. Okay, so I also think this is quite weird, but if you for MSE and SSIM, the result actually not like have a lot difference, and I actually think this should be like a technique issues. We did the skew stripping method on the volume, which means we need to get rid of the skews, the eyes, some part of the image are not brand, and I think we might leave some area in there. So when we add more information into the model, we actually add more like noise there, which making the result look like this. Do I clarify myself? I think this is technique issues, and if we have more clear image, the result shouldn't be look like this, I guess.
Right, but I think that's going to be a common issue no matter what data set you get. And that's what we try to minimize. So anyways, that's what I wanted to know. Thank you.
Thank you.
Wonderful. So any other questions? Gabriella, are you good? You're good?
I'm good, thank you.
Wonderful, thank you. So we do have a few questions from our audience, and so I'll just jump over into the chat box and go through those now. So Jueqi, can you share some example, or can you tell us a little bit more about the medical images you're working on? I believe you mentioned they came from online. Can you just tell us a little bit more about the background of those?
You mean the data set I am working on?
That's right.
These are all online data set, and you can find online, just type the name, and it would give you like register link, and you can download those data set.
Okay, and why would you go ahead with that type of data set? Is there an advantage to using that?
Can you say that again? I'm sorry, I'm a little bit lost.
I'm just not from this field, so I just wonder, is there an advantage to using this kind of data set? Is it easier to obtain, or what was the reasoning behind using this online data set?
My supervisor and I firstly come up with the application, and we want to find the suitable data set online. So that's the way we find the data set.
Okay, awesome. And can you share a little bit about the long-term goals of this project?
The long term of the project is still to develop a robust and versatile deep learning model to solve a variety of medical image estimation problems. That's my long-term goal of it.
Awesome. And we have which MRI is this? By which she means the company. Which company? Do you know?
I think MI is one type of the medical images. You want to see how your what's the sense inside your body, and you want to do the MI and let the doctor or people know what's happening inside it. So that's MI, and that's not the company.
Sorry, I think we have a follow-up here. Simons or GE? Maybe if you jump in the chat, you'll be able to see.
I'm looking at the chat, but I'm not quite sure I understand there.
That's okay. That's okay.
Okay.
I'll give us a second for anyone else. I know we do have a couple audience members here today. If they have any questions, or Noeen, did you have anything else that you would like to follow up with?
No, I am good actually. Thank you.
Awesome. Thank you. Well, with that being said, I would like to thank our judges again for taking the time to be here today, and as well with you, Jueqi, thank you for your presentation today. Our judges, just before we go, do you have any closing remarks that you would like to share today?
Thank you so much, Jueqi. Really appreciate your presentation. And I think you're doing really good work for a first-year student. And all the
Sorry.
Yeah.
I also want to congratulate Jueqi on her work. I think for a graduate student, this is very remarkable, especially since you already got a publication. So that's really good job. And I was really interested in your work, and I found your presentation very interesting as well. So thank you for sharing your research with us.
Wonderful.
Thanks a lot, and thanks this wonderful questions.
Awesome. So I'm just going to share my screen again for a second. And let's see if I can get the right thing. So is it this one? This one. Where is this again? Here we go. Okay. And yeah, so I just want to say thank you again to our judges and to Jueqi for your presentation today. We do have more Science Symposium presentations coming up. If you would like to see where our upcoming presentations are, you can always head on over to the SCWIST Eventbrite, and we have them all listed there. And you can also head over to squist.ca/events, and you'll be able to find them all there and register for any you'd like to attend. Our next Science Symposium event in the machine learning category, it's happening on July 28th, and we will have Dina doing her presentation there. And if you would like any updates on the Science Symposium, you can always head on over to the SCWIST website and check out the Science Symposium catalog. This will be periodically updated with more information about the symposium and what is going on. With that, I would just like to say thank you again to our judges and to you, Jueqi, for your presentation. And yeah, it was really interesting to see what was going on. And we can just close it at that, unless Noeen, you would like to add anything in for our closing comments.
No, I am good. Thanks, Jueqi. It was really wonderful presentation, and I can see I'm not really a machine learning person, but I am a nuclear medicine person, and for that we use sometimes PET MRI machines. That's why I was interested which MRI you are using. That was the only reason. So, but it's okay if you don't know the company. I mean, many times we work with equipment and we don't know the company, like which brand we are using, right? But it was really interesting, and the image resolution was really good in your results. So I hope it can have some applications in future for oncology and neuroscience, which is really needed, especially for neurodegeneration diseases, right? So yeah, and I would like to say thanks to Nidhi and Gabriella, because they are joining us from other continents, right? Like Gabriella is completely from England and Nidhi is from Boston. And thanks, Ashley, for moderating this session. And I think we can close. And thanks, everyone, for joining us. Have a wonderful day. Take care and bye. And come and join us next week, too. Thank you.
Bye.